So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we're going to be proving a crazy infinite product, and that product is this. Just take a look, guys, just take a look at that thing. The product as n goes from 1 to infinity of 1 plus hyperbolic secant of x over 2 to the n over 1 plus secant of x over 2 to the n whole to the 2 to the n. Even further we have, and that evaluates to cosine squared of x over 2 and over hyperbolic cosine squared of x over 2. That's it. Like literally, guys, this is pretty difficult to believe on, but yeah, it's true, and we're gonna be proving this in this video. So I think we are good to go with the proof. Okay, so yeah, I have written the proofs actually, and I think, guys, if you like, first of all, let me just ask you one thing, that if you're finding it difficult to understand like this way of me teaching, like I have written all the solutions, and I'm just gonna explain you like by explaining it to you, right? So if you're finding it any kind of difficulty in this, so you can just tell me. I'll just explain everything by writing by my hand live, right? So and if anything, if there is anything like everything is going on perfectly, so yeah, it's good. So yeah, let's just talk about the proof. Actually, I think this is more convenient because I'm just gonna write everything and it's gonna take a lot of time. And if I have written everything and I'm just gonna explain it to you, although I will explain it to you in deep, don't worry about that. But still, if someone is finding any difficulty about it, so yeah, you can tell me. I'll just fix it over for you. Okay, now let's talk about the proof. So let's consider the argument of the infinite product. Like we are talking about this thing actually, not considering the exponents of that, but we'll consider that later on. But now let's just talk about this one. So yeah, this is what we are having, right? So this can be written as, like, I have written this in some sort of this thing. We can write this as, right? And this becomes 1 plus hyperbolic secant of 2 to the negative n x over 1 plus secant of 2 to the negative n x, right? And again, we have these two formulas by which we can just say that these two are the reciprocals of the hyperbolic cosine of theta and the hyperbolic cosine of theta, right? Respectively. So if you're gonna use those things, so we're gonna have, basically, that's gonna be, this is gonna be 1 plus 1 over hyperbolic cosine of 2 to the negative nx over 1 plus 1 over cosine of 2 to the negative nx. So if you're gonna just like multiply and divide with like here we are gonna just multiply and divide with hyperbolic cosine of 2 to the negative nx, and here we're gonna divide and multiply with a cosine of 2 to the negative nx. So we're gonna have this thing in the numerator and this one in the denominator. So I think so far it's perfect and it's not difficult to understand, right? Okay, so now we are having, this is on where we have the arguments of the product, and we can write this as, look, we have wait a second, I think, yeah, that's perfectly fine. Okay, so basically we can write this as this over this, right? We can write this as this over this and this over this. So yeah, it's just a division, or maybe you can say yeah, division rule, you can say something sort of like that. So yeah, this comes out to be hyperbolic cosine of x over 2 to the n plus 1 over cosine of x over 2 to the n plus 1 and times cosine of x over 2 to the n over hyperbolic cosine of x over 2 to the n. Now using this formula that says hyperbolic cosine of theta plus 1 is 2 hyperbolic cosine squared of theta over 2, and so for the cosine of theta, which says cosine of theta plus 1 is 2 cosine squared of theta over 2. So if you're gonna just plug these, like I'm just gonna plug these here, this one here, after just changing the argument, and this one here respectively. So we're gonna have 1 plus hyperbolic secant of x over 2 to the n plus 1, I'm sorry, 1 over 1 plus secant of x over 2 to the n comes out to be 2 cos, I would say, but hyperbolic cosine squared of x over 2 to the n. And this 2 is this one, actually, this one, this half angle, actually, you know, so you know about that, right? So, and so for the cosine squared. So after just changing these two quantities from these two formulas, we're just gonna have this thing, and we are having this factor as earlier. We just have copied that cosine of x over 2 to the n and over cos of x over 2 to the n. Now we are having 1 plus hyperbolic secant of x over 2 to the n over 1 plus secant of x over 2 to the n. As left hand side we are just running over, and we are just getting rid of these two factors, and we are having hyperbolic cosine squared of x over 2 to the n plus 1. So that's gonna be written as 2, that's can also be written as 2 to the n plus 1. So we just have wrote something sort of that, and over cosine squared of x over 2 to the n plus 1, and that being multiplied to cosine of x over 2 to the n and over hyperbolic cosine of x over 2 to the n, right? Okay, now we're just gonna raise this equation to the 2 to the n power, right? So basically we just have raised both sides to the power of 2n, or maybe exponents of 2 to the n. So we're just gonna have 1 plus hyperbolic secant of x over 2 to the n over 1 plus secant of x over 2 to the n whole to the 2 to the n. That can be written as hyperbolic cosine squared of x over 2 to the n plus 1 over cosine squared of x over 2 to the n plus 1 times cosine of x over 2 to the n over hyperbolic cosine of x over 2 to the n whole to the 2 to the n, right? Okay, so far I hope guys you are not getting confused at all. And again, if you are having if you have any kind of confusion so far, you should just slow my speed, like videos speed, and then you would just get to watch that, and you will just you will just get that, right? And again, if you don't want to do that, so you just have to ask me in the comment section. I will reply over your questions. And again guys, and like, if I'm just explaining it to you, right? So if you are finding any kind of difficulties understanding my explanation, so you have to tell me in the comment section. I will improve it, right? And maybe most probably I'm just gonna have some sort of like a problem of I'm just speaking so fastly. So maybe some people will say, yeah, Aman, you should just slow down your speed. Okay, so yeah, so basically we can just like raise every component to the 2 to the n if all these things are multiplied to each other, and hence so that's gonna be hyperbolic cosine of 2 times 2 to the n. So that's gonna be 2 to the n plus 1 and x over 2 to the n plus 1. So basically this left hand quantity is gonna be hyperbolic cosine of 2 to the n plus 1 and of argument 2 to the negative n plus 1 x. So basically I just have written this thing as 2 to the negative n plus 1 and x, right? So yeah, and so for cosine of 2 to the n plus 1 of argument 2 to the negative n plus 1 x, and cosine of 2 to the n, look, this 2 to the n is gonna be here, and so for here. So basically cosine of 2 to the n of x over 2 to the n and hyperbolic cosine of 2 to the n of x over 2 to the n. So basically we are just running over our left hand quantity with, well, again we just have considered writing this is as 2 to the negative n, and so for this one. So basically we just gonna have okay, wait a second. So basically I'm having this quantity hyperbolic cosine, right, on the numerator. So I think I should consider this one writing in the denominator of this thing, and this like, I hope you all are getting that. Basically I have just replaced the position of the denominator, and that's not gonna bother us anymore. So basically hyperbolic cosine term over hyperbolic cosine term and cosine term over cosine term, that's it. Now that comes the crucial part, I would say. So taking product, big pi notation, actually I hope you are getting that. Both sides from n equals, actually small n equals 1 to small n equals capital N, and later on we're just gonna take that capital N tends to infinity, so that's gonna just give us the infinite product, right? So this product comes out to be here, and the argument that we were playing on so far, and on the right hand side we're gonna have the product as n goes from 1 to capital N of hyperbolic cosine to the 2 to the n plus 1 of 2 to the negative n plus 1 x over hyperbolic cosine of 2 to the n of 2 to the negative n x, and times cosine to the 2 to the n of 2 to the negative nx over cosine of 2 to the n plus 1 of 2 to the negative n plus 1 x. And now since these two quantities are being multiplied to each other, so we can just split this product into two different products, first one with this one and second one with this one. So basically let's just replace this with p sub capital N, so in order to just save some space and save some time as well. And so p sub n is gonna be the product as n goes from 1 to capital N of the same argument that we were playing on. And then we just have splitted these into two products actually, as I just explained you, because we can do that since these two quantities were being multiplied to each other. So we can just split the big pi notation as well into two different products, right? Now considering the first product, so basically this first product is, let's just play around with that. So basically these two things are gonna be some telescoping products, right? Obviously you can just check that out, because n plus 1 and n and some sort of n over n, so you can just think of that something sort of. So basically when you plug small n equals 1 in the first product, so you're gonna have hyperbolic cosine of 2 to the 2 of 2 to the negative 2x over hyperbolic cosine of 2 to the 1 of 2 to the negative 1 of times x, right? Okay. And if we talk about when you plug n equals 2, so that's gonna be hyperbolic cosine of 2 to the 3 and of 2 to the negative 3x and over hyperbolic cosine to the 2 to the 2, and it's 2 to the negative 2x. And if we talk about n equals 3, so that's gonna be something sort of this. You just have to raise this to the 4 and to the 4 as well, and 3. So yeah, and when you plug finally small n equals capital N, so that's gonna be hyperbolic cosine of 2 to the capital N plus 1 of 2 to the negative capital N plus 1 of x over hyperbolic cosine of 2 to the n and 2 to the negative nx. And when you multiply them, so basically this is the first product, so when you multiply all the terms actually, so this is what you will have, right? So take a look at this thing is cancelling out with this one, this thing is cancelling out with this one, this will be cancel out with this another term actually, and the second last term would help us to get rid of this denominator. So basically we would be just left with this numerator and this denominator, right? So here we are left with this product as hyperbolic cosine of 2 to the n plus 1 of 2 to the negative n plus 1 x over hyperbolic cosine of hyperbolic cosine squared of 2 to the negative 1 x. Isn't that amazing, guys? And yeah, believe me, it's the same thing with the second product as well, but we just have to change the order a little bit. But yeah, we'll just get back to there over there, don't worry. So yeah, when you plug n equals 1, so that's gonna be cosine squared of 2 to the negative 1x over cosine squared to the squared of 2 to the negative 2x. N equals 2, so it's cosine squared to the squared of 2 to the negative 2x and over cosine of squared whole to the cube actually, and it's 2 to the negative 3x. And when you plug n equals 3, so that's you're gonna have that much thing. And when you plug n equals capital N, so you're gonna have this much thing. So now again you're gonna multiply all the terms with each other. So you're gonna just take a look at this thing is cancelling out with this one is cancelling out with this one, this will cancel out with the another term actually, and the second last term would help us to get rid of this thing. I'm sorry, the denominator will help us to get rid of this numerator actually, and we would be just left with this first numerator and this last denominator. So yeah, That's beauty. That's literally beauty. So the second term is being evaluated to cosine squared of 2 to the negative 1x over cosine of 2 to the n plus 1 of 2 to the negative n plus 1x. So basically we just have to multiply those results actually that we have got so far. So our p sub n is coming out to be hyperbolic cosine of 2 to the n plus 1 of 2 to the negative n plus 1x over hyperbolic cosine squared of 2 to the negative 1x and times cosine squared of 2 to the negative 1x over cosine of 2 to the n plus 1 of 2 to the negative n plus 1x. And now like we are having this one and this one that is depending on capital N, so we're just going to consider them writing in a single parenthesis, and we'll consider these constants, well, for now as outside, like it's not depending on n if we talk about with respect to x, I'm sorry, n. So yeah, so for that case we are having cosine squared of x over 2 over hyperbolic cosine squared of x over 2 times hyperbolic cosine of 2 to the negative n plus 1x over cosine of 2 to the negative n plus 1x and whole to the raised to the 2 to the n plus 1. And now we just have to take the final limit that says taking limit from, I'm sorry, n tends to infinity. So if we talk about the left hand side, so that's going to be limit n tends to infinity of p sub n, and on the right hand side we're just going to have the limit n tends to infinity with the same things that we are having. So basically it's not depending on n, so it will be treated as a constant, and this is depending on n. So let's talk about this one a little bit. So let's consider this limit as capital L, and here we are good to go with our capital L. So basically capital L is limit capital N tends to infinity of hyperbolic cosine of x to the, I'm sorry, x over 2 to the n plus 1 over cosine of x over 2 to the n plus 1 whole raised to the 2 to the n plus 1, right? Okay, now let's consider x over 2 to the n plus 1 equals u, and now just take a look at this. Like this can be written as x over u equals 2 to the n plus 1, and since when n is tending to infinity, so you must be you must be tending to 0. So now our limit is gonna be u tends to 0, and with this in substitution, right? So basically that's gonna be x over u, and this gonna be u and u, right? So yeah, we are having this much thing actually. Capital L is being written like is being converted to limit u tends to 0 of hyperbolic cosine of 0 over cosine of 0 raised to the x over u. And now just taking natural logarithm both sides, so natural logarithm of L equals x times limit as u tends to 0 of 1 over u. It's just the power rule of the natural logarithm, right? So basically this power is gonna be here, but u is depending u, since u is in limit, so x would be treated as a constant. That's why x here we are out of it, and we are limit at u tends to 0 of 1 over u natural logarithm of hyperbolic cosine of u over cosine of u. Okay, so natural logarithm of u x times, well, we can write this as limit u tends to 0 of natural logarithm of hyperbolic cosine of u minus natural logarithm of cosine of u over u, right? Okay, now let's just introduce some Taylor series actually. Okay, so basically you can think of something sort of this. Since hyperbolic cosine of u can also be written as e to the u plus e to the negative u over 2, yeah. So when you plug u, like when you take limit u tends to 0, so it's gonna be u to the 0 is 1 plus e to the negative 0, it's also 1 over 2, so it's coming out to be 1, right? So basically ln of natural logarithm of 1 is 0, and cosine of 0 is 1. Cosine of 0 is 1, and natural logarithm of 0 is also 1. So basically we are having 0 over 0 form. So in order to get rid of that, we just have to introduce some Taylor series. So we know that the hyperbolic cosine of u as Taylor expansion is 1 plus u squared over 2 plus this higher order quantities actually. Eventually when we gonna take the limit u tends to 0, so we just gonna get rid of all these higher order things, right? And so for the cosine of u, so that's gonna be 1 minus u squared over 2 and plus the higher order quantities actually. As I just explained you, if you're just gonna take the limit u tends to 0, so that we just gonna get rid of these quantities actually. So that's why we just don't need to write all the things, but we can just represent it as a simple quantity actually. And we have natural logarithm of 1 plus y as y minus y squared over 2 plus dot 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 all the way up to infinity. Now we are having natural logarithm of cosine, hyperbolic cosine of u, right? Actually I just missed here a parenthesis as well, so it's not a big deal actually. And minus natural logarithm of cosine of u. So basically natural logarithm of hyperbolic of cosine of u, so it's gonna be natural logarithm of 1 plus u squared and plus like higher order quantities. So basically that's gonna be, if we talk about, if we like look, we are having 1 plus this quantity, so this can be treated as y. So natural logarithm of 1 plus y is y minus y squared over 2, which is, this one is y and this one is bigger quantities actually. So we would be considering this u squared over 2 and plus this big quantities actually. And this big quantities will also consisting of this one as well, so don't get confused about that. And if we repeat the same step, if we repeat the same process with the natural logarithm of cosine of u, so we're gonna have negative u squared over 2 as sorry guys, as y, and rest of the things would be considered as higher order, higher degree terms or higher order terms actually. And now let's just get back to natural logarithm of L. It was x times limit u tends to 0 of, so basically natural logarithm of hyperbolic cosine of u can be written as u squared over 2 plus the higher order things, and minus natural logarithm of cosine of u can also be written as minus u squared over 2 plus higher order stuffs. So basically that's gonna give us u squared plus u squared, u squared over 2 plus u squared over 2 and plus higher order stuffs over u. So that's gonna be u squared, and natural logarithm of L is coming out to be x times limit n tends to 0 of u squared plus higher order stuffs of u to the fourth you can consider over u. And now if you're gonna just cancel like if you consider taking out u here, so it's gonna be u to the 1 plus the higher order as u and u cube you can say. So yeah, we just gonna get rid of all this denominator, right? And we would be not suffering from 0 by 0 form so far. And now if you plug u tends to 0, so it's 0 0, basically it comes out to be x times 0, which is 0. So natural logarithm of natural logarithm of L is coming out to be 0, which is L is e to the 0, which is 1, and here it is. So basically this limit actually that we have to solve, actually this limit is 1. Isn't that amazing, I would say? So basically we just got rid of this thing, and finally we are here with our this quantity, that limit capital N tends to infinity of p sub n is cosine squared of x over 2 over hyperbolic cosine squared of x over 2. And here it is, limit n tends to infinity of p sub n of cosine squared of x over 2 over hyperbolic cosine squared of x over 2. And our like p sub n was n, so since n is tending to infinity, so we can just replace that n with infinity. And here we are having the final product that says the product as n goes from 1 to infinity of 1 plus hyperbolic secant of 2 to the negative nx over 1 plus secant of 2 to the negative nx. Oh, I'm sorry, I did messed up here, 2 to the n as well. So these things are being converging to cosine squared of x over 2 over hyperbolic cosine squared of x over 2. So this is what we are having, and yeah, this was amazing. We just have to go through a lot of stuff actually. Yeah, this is amazing guys. So I think it's good, it's perfect. And again guys, if you got to learn something out of it, you just have to make sure to just like subscribe and share. And again, I just I'm requesting you to just, if you have any kind of doubt so far, you have to ask me in the comment section. I'll be there to reply over your questions, definitely. And just stay tuned for the next video guys, because I'm just gonna bring a lot of things for you like this. And like my major focus would be, and basically is, or I have had major focuses in mathematics to generalize stuffs, like just with it here. And I will be doing this forever, maybe till my last breath. I'm not sure about that. Okay, goodbye guys, love you, take care, and study. No, not study actually, learn and have fun with mathematics. Because if it like if you have any kind of if you are having fun in it, you are really studying mathematics. Yeah, that's cool. I'm just waiting it to be 25 minutes, and here it is.